Hey guys, welcome back. I hope you had a wonderful weekend. If you haven't heard the good news yet, we are actually ahead of schedule, so I'm not going to be giving you guys assignments on Wednesdays anymore, except next Wednesday because it's the Wednesday before fall break and you're going to take a test. So yeah, next Wednesday you guys got a test over this stuff, but we still got a few more things to go over before then, so don't worry about it. All right, so I do want to review vertical angles. In fact, a basic proof of vertical angles. So if you remember, vertical angles are angles that are opposite of each other on an intersection. So what's special about vertical angles is if this is 108, the vertical angle over here is also going to be 108. The way we prove that is with supplementary angles, and they're, in fact, in this case, they're linear pairs. So if we look at this blue line here, the angle formed by the blue line is going to be a straight angle, which is 180 degrees. So if this is 108 of it, the supplement of that, which would be 180 minus 108, would be 72 degrees. So if this angle is 72 degrees, then we know the supplement on the other side for the purple line is also 180 degrees. So 180 minus 108 is going to be 72 as well. So what we just proved is that the vertical angles are the supplement of the same value, which would be 72 degrees. So they have to be congruent to each other because they're both the supplement of 108. And if we did the same thing for the purple line down here, the supplement of 72 is going to be back to 108. So once we know one angle of an intersection of two lines, we actually know all four of them just by using supplementary angles. And that's actually how we prove the vertical angles are congruent. So on this one, if we have 108 plus something is going to be equal to 180, and that something would be 72, which is its supplement. So I want to go over corresponding angles again. So remember when we have two parallel lines, so here we have our parallel lines A and B, and then our transversal which cuts those two parallel lines, the angle that it cuts and forms with one parallel line are going to be the exact same angles that are formed by the other one. So if you notice here, if I move this line up here, the angles that are on the top right is the same as the top right. In fact, all the angles are exactly the same because they're pretty much the same line, except the parallel is just moved down here. So let me see if I make sure I put it exactly where it was. All right, so what we have with corresponding angles is when we have a transversal cutting two parallel lines, the corresponding angles mean the angles that are in the same location are going to be congruent. So this angle here, 68 degrees, is in the top right of the intersection of this transversal and this parallel line. So if we move down the transversal on the top right, it's also going to be 68 degrees because they're corresponding. Then if we look at the supplement of 68, which is going to be 112, the supplement in the top left-hand corner is going to be the same. Going down the transversal in the top left-hand corner is also going to be 112. Then if we do the supplement of that one, which would be vertical to this one, 68, and the bottom left-hand corner going down the transversal is 68, and of course, following the same logic, these are both going to be 112 as well. So if you notice, if we know what one of the angles are, up here or on any part of the transversal cutting the parallel, then we know all four of them, and we know all the angles following the transversal on the other parallel line as well. Now, what's nice is once we know these angles, we can actually come up with pairs of angles that we can have special names for. Yeah, so like one of them is alternate interior angles. So alternate interior angles are angles that are on the alternate side of the transversal, but the interior of the parallel lines. So an alternate interior angle would be, for instance, this 68 and this 68 here. If you notice, they're on alternate sides of the transversal. One of them's on the left side, one's on the right side of the transversal, and they're both on the interior of the parallel line. So one's down there and one's right here. So 68 and 68 would be alternate interior angles because they're on the alternate side of the transversal and the interior of the parallel lines. And what's special about alternate interior angles is they are actually going to be congruent to each other. Another one we have is alternate exterior angles. I'll show you that one tomorrow, but I'll go ahead and show it to you today anyway. So it's the same idea. They're on the alternate side of transversal, but now they're on the outside. So if we look at this 68 and the 68 down here, they're both on the alternate side of transversal. One's on the right side, this one's on the left side, and this time they're on the exterior of the parallel lines. No big deal. And what do you notice about the alternate exterior angles? They're also going to be congruent. Then we have, let's see if it'll change. Then we have same side interior angles. Now same side interior angles are on, instead of the alternate side, now they're on the same side. So you can probably imagine what those would look like. So for instance, we can do 112 and the 68 here. So 112 and 68 are both on the same side of the transversal. They're both on the right side in this case. And they're both on the interior of the parallel lines. And what's special about the 112 and the 68? Well, they are supplementary. So we say same side supplementary is how we remember that. Then the last one we have would be same side exterior, which typically that doesn't even show up on the test, but it is a thing. So I'll go ahead and give it to you. Same side exterior is just like same side interior, but now we're dealing with angles that are on the outside. So we could do these two over here. So for instance, 112 and 68, they're both on the same side transversal, the left side this time, and the exterior of the parallel lines, and they are same side supplementary as well. And that's how I remember those. So alternate interior and exterior are congruent, same side interior and same side exterior are supplementary. And it's just a short way of once you know these names, it's basically just a shortcut instead of having to do corresponding and vertical each time. So let's go over corresponding angles again. So if we look at angle 1, that's on the top left of the two parallels, which we know from these triangle symbols, and it's on the green transversal. So which one corresponds with 1? Well, that would be the 5 down here. Be careful because this 1 does not correspond with this angle right here. We don't know what that angle is, and the reason they don't correspond, even though they're both in top left, is because the green and the blue line are two different transversals and they're not parallel to each other, so we can't go across from here to here. We can only go down the transversals, and because those two aren't parallel, those are not transversals. Okay, then also 3 would correspond with 7, 6 would correspond with 2, 4 would correspond with 8, etc., etc. So which one corresponds with 14? Now remember, again, it's not going to be 2, even though they're both on the top right-hand corner of the intersections, because this is now the transversal among two parallel lines, because clearly these lines intersect right up there, right? So 14 is in the top right of the blue transversal, so we go down the transversal, that's going to correspond with 10, and 16 is going to correspond with 12. All right, so now we're going to look at some alternate interior angles. So if you forget, these are alternate interior angles because they're on the alternate side of the transversal. This one's on the right side, this one's on the left side, and they're both on the interior of the parallel lines. So that's where we get the name, alternate side of the transversal, interior of the parallel lines. And what's special about alternate interior angles, if you remember, they are congruent, meaning their measurements are equal. Now, how can we prove that they're congruent? We can actually prove it using corresponding and vertical angles, which is why we spent so much time doing that on Friday. So if you forget how they relate to each other, just go back to what you know with corresponding vertical. So if this is on the bottom right, we can follow the corresponding angle down the transversal on the bottom right here, which would also be 100. And then you can see how these two are related to each other. They're vertical angles, which means they have to be congruent. So if this is 100, that means this angle here also has to be 100 because alternate interior angles are congruent. So what we're doing here is we're kind of memorizing shortcuts or algorithms. So if you've ever solved a Rubik's Cube, or if you know kind of how it works, I've never actually solved one, but I know kind of the patterns and how it works, is that you end up with some algorithms, which are just patterns of different ways that you twist the top, or you twist the middle, etc., and then you twist the other side, and then you go back, and etc., etc. So these patterns are just kind of like little shortcuts, or like if you think of like a cheat code and you like punch in a certain series of numbers and that does something, right? So after a while, you don't even have to think about the series and it just kind of comes to you and you just perform the move or whatever. It's the same thing here. So instead of having to fill in all the angles on the top and the bottom, if we notice that these two angles are alternate interior, meaning alternate sides of the transversal, interior the parallel lines, then we can go straight to, oh, they have to be congruent because they are alternate interior angles. So that's the whole point of naming these, and you'll need to know the names for the test anyway. So the next one's alternate exterior. So notice on this one, they're still on the alternate side of the transversal. One's on the left side, the other one's on the right side. This time it's only different because they're both on the exterior of the parallel lines, but alternate exterior angles, just like alternate interior angles, which they're vertical with, are going to be congruent to each other. How can we prove this using corresponding angles? Well, if this is 130 on the bottom right, we can move the 130 on the bottom right here, and then you notice these two are vertical to each other, so they have to be congruent. Now we have same side interior angles, which are both on the same side of the transversal, but both on the interior of the parallel lines. Okay, so they're same side of the transversal, interior of the parallel lines. Same side interior angles, if you remember, are same side supplementary, okay, which means they add up to 180. So they sum up to 180 degrees. So in case you forgot that, we can move this one to corresponding. So it's on the bottom right, corresponding is going to be bottom right here. And if we notice these two angles, they're a linear pair that form this green line. So they add up to 180 degrees. So what's the supplement of 100? Well, supplement of 100 is going to be 80, right? Yeah, so 80 degrees. If we're being fancy. All right, cool. No big deal.
All right, then we have same side exterior, which you probably already know, are same side supplementary again. They're same side and exterior because they're both on the same side of the transversal, both on the right side, and they're both on the exterior of the parallel lines. So the reason they're supplementary is because we can move the corresponding angle from the bottom right to the bottom right here, moving up the transversal, and then you notice, oh, these two have to add up to 180, so the supplement of 130 is going to be 50 degrees. There we go. So x has to be equal to 50. All right, so just a little bit of practice because sometimes you get some complicated diagrams here. So don't be fooled. We have two transversals that are crossing two parallel lines. So which one is going to be, which one corresponds with angle 1? So angle 1's on the top left. So the top left here, no, don't do that. Why? Because we got to follow the transversal. So follow the green line. The one corresponding with it would be 9. 3 corresponds with 11. 2 on the blue one would correspond top right on the blue one of 6. 4 would correspond with 8. So don't be fooled by that. All right, do you remember what's special about alternate interior angles? They are going to be congruent angles. So give me an example of an alternate interior angle with 3. So 3 is right here. The alternate interior 3 would be 9. And the reason for that is they're on the same transversal, okay? They're on the alternate sides of the transversal. One's on the left side, one's on the right side. Okay, I said those backwards, you get the idea. And they're both on the interior. And what's special about them, 3 and 9 would be congruent to each other because they are alternate interior angles. And that's how alternate interior angles work. All right, what about alternate exterior? So give me an alternate exterior with 2. So alternate exterior with 2 going to be on the blue transversal. Alternate side, if that's on the right side, we're looking at the left side. So that would be 8 right here. So 2 and 8. And again, these have to be congruent to each other because corresponding one would be 6, then vertical with 6 would be 8, so they are congruent. What about same side interior? Same side interior or same side supplementary. Same side interior angles would be, for instance, 3. It's going to be same side interior with 10. So same side or alternate interior would be 9, which would be congruent to it, but then the supplement of that would be 10, right? So 3 and 10 are supplementary. Also, we know that 4 and 5 are same side interior and supplementary as well. Same side exterior, same idea, but you won't see that one on the test, so don't worry about it. They're going to be supplementary as well. So 2 is same side exterior as 7, and 1 is same side exterior as 12. And those are the only examples we have. All right, you want to do another one? Might as well. All right, so alternate interior with 3 would be 5. Alternate interior with 4 would be 6, okay? Alternate interior with 16 would be 10, and that's all that we can do. Alternate exterior, so 1 would go with 7, 8 would go with 2, 14 would go with 12, okay? And same side interior, 3 and 6, 4 and 5, 16 and 9. And again, 3 and 16 are not same side interior because that's not our transversal and these lines are not parallel. Clearly they intersect there. And if it's parallel, it's going to be marked with either a triangle or a little chevron. Same side exterior, 1 goes with 8, 7 goes with 2, 14 goes with 11, and that is it. All right, so if you get out your assignment, it was only 13 minutes, not too bad. So on number 1, we want to identify each pair of angles as alternate interior or alternate, this should say same side interior. My bad. You get the idea because it's going to be annoying. All right, then find the measure of each angle indicated. So on this one, they are both on the same side of the transversal. They're both on the right side, and they're both on the interior of the parallel lines. So these are going to be same side interior. And you can just write that abbreviation and AIA. And on your answer bank, that would be one of your answers. So same side interior, you can cross that one out. All right, now if they're same side interior, that means they're same side supplementary. You might even go ahead and write that in there so you can keep that logged in your brain. So same side supplementary means they add up to 180. Now, if we weren't sure about that, we could actually prove it by using corresponding angles. And if you want to do that too, you can. So we can either move the 99 up or move the question mark down. We move the question mark down. So on the bottom right here would be the same one. Now it's easier to see their same side interior because we're right next to each other, but we can keep moving it down again, and then we'll notice that, oh, they are supplementary because they add up to that line, which is 180. So our answer is going to be 180 minus 99, which is equal to be 81. Yeah, so our answer is 81 degrees, of course. That is totally caps lock. There we go, because it matters. All right, number 3. So on number 3, we would identify them. So they're not on the same side, so we already know it's alternate. This one's on the right side, this one's on the left side of the transversal. They're both on the interior, so these two would be alternate interior. So AIA, alternate interior angles, which are congruent. If we're not sure if they're congruent or not, just move the corresponding angles. So 107 could go down here to the bottom right, 107, and now you know they're vertical. You also could have moved the question mark up here to the top left, and they're vertical there either way. So it doesn't matter how you solve it, but they are congruent. So if this is 107, that means the question mark is also going to be 107. So that's your answer. No big deal. All right, number 7. So looks like we've got same side of the transversal, interior of the parallels. So same side interior, which means same side supplementary. Means they add up to 180 degrees, and that's how we're going to set it up, okay? So take your two expressions. If I wanted to, I can move the 93 up or move this one down, which is what I think I did. And then clearly you could see that they are supplementary. That's not required if you don't want to do that. Wouldn't bother me. Okay, once we know they're same side interior, we automatically know they're supplementary, so you don't have to move the corresponding angles to prove that they add up to 180. That's the whole point. It's like knowing the cheat codes or the algorithms to help you solve the Rubik's Cube. All right, so add up the expressions. The 13x minus 4 plus the 93 is equal to 180. Combine your like terms. They'll give you 13x plus 89 is equal to 180. Then we're going to subtract 89 from both sides, leaving us with 13x is equal to 91. Then we divide both sides by 13, leaving us with x is equal to 7. Isn't it nice when I do the math? Now, I'm hoping that's right. I'm pretty sure I like double checked, so I didn't have any more issues on today's. All right, identify these again. Just ignore those directions because they are off. I forgot to change them. So on this one, they are on the alternate side of the transversal. One's on the left side, one's on the right, but they're on the interior of the parallel lines. So again, these are going to be alternate interior angles, which means they are congruent. And if we weren't sure, we could move this expression up here. We can move it up there. Okay, weird. Then move it up there, and then you see that they're vertical to each other. So either way, no big deal. Alternate interior angles are congruent, so set their expressions equal. 15 plus 5x is equal to 75. Next step, we're going to subtract 15 from both sides. So we get 5x is 60. Divide by 5, we get x is equal to 12. Number 16, same idea. We've got the same side of the transversal. They're both on the left side, and they're both on the interior of the parallel lines. Okay, so these are going to be same side interior angles, which are supplementary. That was terrible. Okay, supplementary, meaning they add up to 180. So add them up, set them equal to 180. Combine your like terms. 5 plus 35x is equal to 180. We're going to subtract 5 from both sides, leaving 35 is equal to 175. Divide both sides by 35, leaving x is equal to, I think, 5. Almost said 7. Oops. And that is it. We're done. Awesome. So 18-minute video. You're welcome. Breezing through that. If you guys have any questions, I'll be on Google Meets 11 o'clock. I'm going to try to post those links. We are using the exact same link for the entire year for Google Meets. And if you want to know where that link is found, I put it in with the syllabus towards the very bottom. You can also use the little tab in Google Classroom for the syllabus, and it'll tell you the Google Meet code. But I'm also going to be posting it a few times just in case you guys don't know where to find it. So I'll be posting it on the stream. So I'll see you guys later. Have a good day.